All right, welcome back again. This time what we're going to talk about is timers with interrupts. So we're going to keep talking about timers, but we're going to kind of introduce you to the next big topic, which is interrupts, kind of what they are, and we're going to do it in a hands-on way. So what I want you to do is I want you to grab the timers with interrupt code. Actually, go ahead and go into MPLab, make yourself a new project first. So same deal as always, right? Made a lot of projects today. So 18F4520. Make sure that you've got your board handy. Compiler. So this one's going to be called Timers with Interrupts. Big topic, big topic. All right, so timers with interrupts. It's going to require the LCD. So I'm going to go ahead and say include LCD module .h. And then it's going to also need in the source files LCD module.c. Remember with those, we just leave them as that name. And then much like before, you're going to start with a little starter snippet. You're going to grab it from above, but I'm going to grab it from right here. And I'm going to save that link into my folder I just created. So timers with interrupts, it's going to get saved right there. And inside MPLab, I'm going to right click and I'm going to say add existing item. And I'm going to go to the correct folder and add it there. Great. So this actually does some stuff which should compile and run. So if you would like, you can go ahead and compile and run it. And what it does, I hate that question. Grr. What it does is it prints the timer 0, and so you can see timer 0 is running. And in addition to printing it on the LCD, the LEDs will change whenever it rolls over. So you can see that the LED changed when it rolls over. It started every time back at 0, and the LED is about to roll over. So it's displaying on the LCD, just like we did before, but it's got this additional magic with the LCDs, or with the LEDs changing. Let's go in and look at the code just real quick. First thing you'll notice about the code is that there's all this new stuff that says the word interrupt and ISR and stuff. We're going to get into that more when we talk about interrupts fully. But interrupts have this boilerplate code that's always the same. It never changes. Looking inside main, here's some stuff you recognize. Setting up the clock, setting up the timer with a 128 prescaler. Took about 8 seconds to overflow, 8.4 to be more exact. And then here's some new stuff. We're saying turn on global interrupts and peripheral interrupts. We'll talk more about these next time. I just wanted to introduce them to you kind of gently with an example today. And then all it's doing in the main function is it's just printing to the LCD the timer. The big thing you want to pick up this time is that there's no code in here, like in main, that changed the LEDs. There's just none. The code that changes the LEDs is inside this interrupt service routine. What's happening in here is whenever there is an interrupt from the timer, clear that flag off because we're going to handle it. And then this line right here is what increments the port C LEDs. The way this works is with an interrupt. There's an interrupt that triggers whenever the timer rolls over. So whenever the timer rolls over, it calls this function. That's all interrupts are. It's just a function that gets called by hardware and not by your code. And we've set this up to get triggered because we said that interrupts were on for timer 0, and we've also enabled them globally. If you wanted to turn this interrupt off to make the lights not happen, all you would have to do is you would just have to say interrupts off. So if you just changed from on to off, that would kill them. Another way you could kill them is here we're enabling globally, we're enabling all interrupts. If you just commented that line out, that would also kill them, and it would let no interrupts happen. So those are kind of two things you could do. You could try those if you wanted. Believe me, they work. So what I want to start doing is I want to start making changes. What I'd like to do as a first change is I'd like to say write timer 0. I would like to write it to 30,000 whenever there's an interrupt. So if you do this and you run it, the code will behave just as it did before, with one exception, and that is the timer is going to start at 0. So notice that it did start at 0 and not at 30,000. It started at 0. Once it gets up to 64,000, 65,000, it does the lights, and it resets to 30 instead of to 0. So you can see that this code is making the interrupt happen much faster. All right, so now it's your turn to do something. The way this code is working is it's starting at 30,000 and it's counting up to 65,535. So 535. So the actual number of ticks is the difference between the two. So that's how many ticks there are. So whatever, 25,535. So that's how many ticks there are. That, of course, takes a certain amount of time. What I want you to do is I want you to set it to where it takes exactly 1 second. To encourage you, I'm going to also say to use a pound define. I'll just call it, start time, just because we don't like magic numbers. And we're going to say up in the pound define area up here, pound define, start time. So 30,000 is not the answer. But I want you to figure out what the answer is. Also, I think that we should also put this to where it happens the first time as well. And what you can do is you can do that just before the main while loop. So that way the first time it goes in 1 second as well. So your challenge is to figure out what does this number need to be in order to get exactly 1 second. All right, see if you can do that. Okay, I'm going to do it as well. So we've got a 4 megahertz clock, which is great. We've got a 128 prescaler. And you can actually cheat because if you've got a 128 prescaler, you know that each timer tick is going to be 128 microseconds. That's that shortcut math that works for a 4 megahertz clock. So if we wanted 1 second, we know that we're going to need 7,812 clock ticks. However, we don't start the clock there. We start it at 2 to the 16th minus that value. So we actually want this number here, 57,723. I really don't care which way you choose to round, right? I don't care if you round up or down. I'm just going to truncate it. And so if I run this guy now, what it should do is it should update my lights every 1 second. And it should do it very, very accurately, right? So this is actually the best way to make time delays. So if you want something to go off every second, it's best to use it with interrupts. And this clock is very, very accurate to be 1 second. The other nice thing is you can see the main loop is totally free. It's still printing the numbers. So you can do whatever you want in the main loop. So I think that's kind of neat. All right, next little challenge for you. Let's say that we wanted to print not only timer 0 on the LCD, but also timer 1. So what we're going to want to do is instead of printing just timer 0 on line 1, let's also read timer 1. So I'll call it result 1, and I'll put it on line 2. So I'll just kind of change this with you. What I'd like for you to do is I would like for you to write the code that opens timer 1 with the slowest prescaler it's got. So take a minute and see if you can do that. Okay, I'm going to do it with you. So I'm going to start the way a lot of people start, and that's to copy this line and to start changing things. Most people are pretty good and say, hey, I'm going to need to open timer 1. From there, though, some people start to leave way too much. And things that they might leave is they might leave these constants. So this says timer 0 16-bit, so you probably are going to want timer 1, right? That's obvious. Timer 1 source internal, and you would like to use a timer 1 prescaler. However, you can see it didn't like some of these words, so let's figure out what these words should be. The way you figure out what the words should be is your library functions. So your library functions are telling you that you have the ability to do 8-bit or 16-bit, but for some reason the constant adds the word RW to the end. I'm sure it stands for read write, but I'm not sure why it's different. So RW, and you can see that now it's much happier. Then we tried to use a 128 prescaler, but the slowest prescaler is actually 1 to 8. So it's going to be pretty fast. So the slowest one is not 128, it's just plain old 8. And for now, what I'm going to do is I'm going to turn interrupts off. So I'm going to go ahead and run it. And what I'm hoping happens is I'm hoping that it prints on line 2 the timer 1 value. So now it's printing timer 0 in the top line. It still should be doing my lights just like before. Oops, my lights are not happening. And then timer 1 is humming away down here, going quite quickly. So I've got to figure out why my lights didn't work. Whew, that one caught me a little off guard too, so I figured it out. So the problem was kind of detailed. The problem was that RC0 can be used as different things. One of the things it can be used as is the timer 1 oscillator, so you can actually output the timer pin there. And if you look carefully in the library, one of the things you can do is you can disable that oscillator output. So T1 oscillator 1 enable off is a line of code I had to add. I didn't see that coming. So that guy right there you needed to add, and that frees up RC0 to be used as digital I/O again. So just by adding that little addition, so you should add that as well, and then hitting play, what should happen is it should display both timer 0 and timer 1, and your lights should go off at 1 second, no problems. So the whole idea of interrupts is they're kind of a way to simulate like multi-threading, right, or like multiple things happening at seemingly the same time. Last thing we'll do today, we'll do it together. If we wanted to, we could actually turn on interrupts for timer 1 as well. So I switched it from off to on. If you turn on interrupts, it's going to call that function. You sure better handle it, because if you don't handle it, badness happens. Let's just prove it, right? So if you try to run it without handling the interrupt, what's going to happen is it's going to essentially hang the program. So it's going to start running, and then the LCD screen is going to be completely hung. So the LCD screen will never get screened. You'll notice the interrupts actually keep going off, which is interesting, but the LCD screen is hung. And the reason it's hung is because if you don't handle an interrupt, it calls the interrupt ISR again and again and again and again, and it never goes back. So let's introduce you to handling interrupts. What you have to do is you have to know the special name of the flag that got set. We're going to go into this next time, but for today I'm just going to tell you. The flag that gets set is this guy right here. This is PIR1 bits.TMR1IF. So that's the flag that gets set whenever this interrupt goes off. The way you know that is you can look up in data sheets, or you can wait till next time and we'll give you a whole list of all the different interrupt flags. By the way, you might have expected it to be inside the int-cont special function register, but that special function register is only 8 big, and it can't hold everything. So this bit is actually in some other special function register. Just so we can do something in here, let's say port C bits.rc7. Let's just toggle it back and forth. I'll be fancy and I'll toggle it with this shortcut. I'll exclusive OR it with itself, which means if it's 1, it'll become 0, and if it's 0, it'll become 1. But it's just a fancy way to toggle that LED every time timer 1 overflows, which will actually be quite fast, right? So the main one should count every 1 second, and this guy should just kind of be flashing his head off. And the LCD screen is back to functional. So the goal for today was to introduce you to interrupts with a hands-on example, let you see these interrupts, that they go off, and kind of introduce you to this concept of interrupts are just functions that are called when the hardware senses certain events, like a timer overflow. All right, that's it for timers. You know way more than you did when you started this day. We'll see you next time where we talk more about interrupts. See you then.